My name is Taylor Riggin. I'm a senior graph architect here at AWS, working on the Amazon Neptune team. I've been here at AWS for about 5 years now. I've been working with customers ever since we launched Neptune back at re:Invent 2017 on building applications using graph and graph databases. Everything from recommendation engines to identity graph applications like we're going to talk about today. So if you have any questions toward the end of the session, please hold your questions, and at the end of the session we can address any of those. So today we're going to talk about a graph overview. How many of you have actually used a graph database before? Okay, handful. So we're going to cover graph in general a little bit, just to give everybody a baseline of what we mean when we talk about graph and a graph database. Then we'll go into the Customer 360 use case. And just some general information around what we're talking about when we talk about Customer 360, identity graphs, and all the different types of applications thereafter. Then I'll go through a handful of demos. I'm actually going to get into the console, show you Neptune, and then some of the example assets we have around Customer 360 that you can then take and use to your own devices. And then we'll also go over some other resources to get started with Neptune. So why graphs? Graphs are cool first, right? In general, most people, when you think of data, intuitively you kind of think of data as a graph. I mean, how many people here have ever used a mind map before, right? It's very intuitive to kind of think of how data is connected in terms of entities and drawing relationships between them. But as you can see here, this is kind of one kind of canonical model of a graph, right? You typically model data in a graph structure as things that are nouns or people, places, etc., as vertices or nodes. And then the verbs or actions that connect those as the edges or relationships in a graph. For example, here we have Alice. We can actually denote Alice as a vertex in the graph, and then a place, any town or some city, etc., as a vertex, other people such as Bob. And then we can draw direct relationships between Alice and Bob as a works with relationship or friends with relationship as an edge in the graph. Similarly, also, if we wanted to know where Alice lives, we can actually create an edge called lives in to denote that Alice lives in any town. So this is very representative of what you see with customers and how they actually model data. Traditionally, if you were to take a data set and put this in a relational database, a lot of times you're taking the entities and building out tables, and then the relationships end up being these kind of tenuous things that you create by using primary and foreign keys between tables, where those relationships have to be created at query time, so to speak. And it can be a little bit difficult sometimes to query that data using a relational database. And that's really where graph databases shine, is they have the query languages and the syntax to be able to query across relationships. So what are some common graph problems that we typically see? Fraud. So if you're trying to model customers and transactions and where a transaction came from, maybe it came from an IP address or a certain physical address, and you're trying to determine the source of fraud, it's really easy to represent that inside of a graph and trace across the graph to find the common points where fraud may be occurring, right? Think of this in terms of just like credit card fraud, right? You may have a situation where people are using the same business location to generate fraudulent transactions. You can actually see that in a graph by seeing so many connections coming from that one physical place. Recommendations. If you ever go to Amazon.com and you pull up a product page on the website, the very bottom of the page, you'll see something akin to people who have purchased this product have also purchased, and then a list of items. That is easily computed using a graph algorithm called collaborative filtering, where you actually can represent the product as a vertex or a node in the graph, traverse across an edge from a transaction standpoint to a user who purchased that product, and then across additional edges that represent transactions to other products they've purchased. And then it becomes an aggregation exercise to aggregate what are the most common products that the users have purchased, that original product have purchased. It's a very common recommendation pattern. Siloed data sources. Anybody in here has ever done anything with master data management and trying to draw this field that's representative of a username with a first name, last name, et cetera, and how do those all connect? It can be very difficult sometimes. And a graph can do a really great job of taking all of the attributes from multiple data sets and stitching those together to create a common attribute that you can use across all of your data. If you're trying to link identities, and we'll talk about this a little bit today, right? One of the very common things that we're seeing now with the discontinuation of things like third-party cookies, people are trying to draw the relationships of anonymous users that are going to their web properties to known users. So when my wife, for instance, goes and starts looking at new insurance to buy, all of a sudden I'm starting to get ads in my social media feed for insurance, right? That's something that advertising companies are using identity stitching to figure out, that my wife and I live in the same household, and maybe they can actually target ads to both of us off of common search criteria. Another one, and this is not one we won't necessarily talk about too much today, but we're starting to get more into using graph for generating machine learning models. There's a framework that we actually use inside of Neptune. We have a feature called Neptune ML. It's a framework called the Deep Graph Library, or DGL, that we're beginning to use to generate graph neural networks that, based off of what we've seen from academia, have had a better success rate at making predictions over traditional machine learning frameworks. A lot of this comes down to just how connected data is and how you can use those connections instead of the attributes and features of the data to derive predictions. So what are some of the other types of use cases that may not be as well known? Supply chain problems. We see this very common problem we're seeing today, right now. Trying to draw where are the bottlenecks in my supply chain. It's easy to model out a supply chain as a graph. You can put all the different locations and even inside of a factory, you can put all the different components of the manufacturing process into a graph and be able to trace across those chains and see where the bottlenecks are in the manufacturing process. Where does data come from? Data lineage. We're starting to see, similar to MDM, but in this case, we're looking at, I have 100 data sources that my business uses, right? Those data sources may get manipulated into additional internal data sources. Those internal data sources may get manipulated into reports. How do I determine, looking at a report, what the source data was and what other computated fields that I have in additional internal data sets were used to derive this report? And so we actually have customers that are using Neptune and Graph for this type of use case. There's actually a project out there, an open source project called Munson, which has become very popular for people to build data lineage use cases on top of. What search results relate to my question? This right here is probably the one common graph use case that everybody uses every day right now. If you use Google, right, Google was originally derived off of an academic paper called PageRank, which was really looking at different websites and how they were linked together. So when you actually searched across a site, which site had the greatest number of links or connections to it? Now, Google is a lot more complex today as far as determining your search results. But ultimately, this comes down to using Graph for that type of problem. We're starting to see more use cases where people are using Graph to represent knowledge from a corpus of data and be able to actually use Graph, not just for PageRank results, but also for things like semantic search. So if I'm a law firm and I have a corpus of documents and I'm looking for a single entity, a single person, and I want to know what other documents that their name is not in that I want to go look at for legal review, right? I can look at the common connections from that document to other documents that have similar entities and to be able to actually search across that corpus of data to know what I should go review. It's a very common way of using Graph in that use case. How does person X have access to information Y? Security entitlements, right? If you were to take IAM, for instance, and model that as a graph, you can trace across the graph easily to see what a person has access to. I see this a lot with CloudTrail logs now. People actually taking CloudTrail logs and looking at who assumed what role and what role is being used to access what component within AWS. Price curve change impact, just impact analysis overall. using a graph to represent how changes in a system can affect outcomes. So overall, graph can be used to solve the where, the why, the how of different types of these different types of use cases. And the kind of 6 canonical examples of a graph-based application, you can actually see here. Social networks, everyone's used things like Facebook, Twitter, LinkedIn, et cetera. Those are all very representative of a graph. Identity graphs, we'll talk about those more today. Fraud detection, entitlements, network analysis. We're starting to see a lot more customers use, not just for CloudTrail logs, but taking things like VPC flow logs and other network trace-related information and use that instead of a graph to look at how their cloud-based networks are structured. There's a plethora of security-related companies now that are using graph to look at the security posture of your cloud environments. And then knowledge graphs. Knowledge graphs not so much a use case, but kind of a higher level framework for representing knowledge within a graph structure. And so when customers build these applications on AWS, they're using Neptune primarily, but sometimes they'll have to use other database services as well. We have a vast catalog now of purpose-built databases specific to the access patterns that you need for the application, right? An application may require multiple different access patterns, so it may require multiple uses of multiple of these data persistency layers. So let's get a little bit more into Customer 360 specifically. So as I kind of mentioned, we're starting to see this used in a number of different verticals. Advertising and marketing uses this type of pattern quite a bit in terms of trying to target ads for customers, but also for products, product positioning and customer segmentation, looking at what attributes customers have in common, and also mapping out customer journeys. So if you have a customer that comes to your website, how do you trace where they came into your website, where was the entry point to actually converting as a purchase? If you're a website developer, this is very important to understand is how can I actually shorten that path to get a customer to my site and convert to a purchase in the fastest way possible. Householding, I already kind of gave you an example of this, right? 2 users, and this doesn't necessarily have to come from a single household in general, but 2 users coming from the same group or category, how do you group those people together to actually do certain advertising, marketing, and product positioning? So some of the technical challenges, we've seen customers attempt to do this sort of thing in relational databases. It requires some work if you're trying to do this in a relational system, right? In terms of just creating the proper indexing schemes, if you're trying to traverse across something iteratively, having to use things like common table expressions and SQL, it's not intuitive to model a graph-like structure in a relational database. And from a customer segmentation perspective, we've also seen customers attempt to use things like data warehouses, where they're denormalizing the data, but that can also limit you in terms of the number of fields that you're searching on, right? So if you're doing 2, 3, 4 fields, that might work. If you start going beyond that and segmenting across dozens of fields, that may be problematic. We do have customers using other graph solutions. So Neptune's not the only graph database out there, but graphs can be hard to scale, right? Cap theorem is difficult. And so trying to partition a graph across multiple instances is a non-trivial problem. And trying to scale this and work around some of the performance constraints is something that you don't necessarily have to be dealing with all the time. So having a managed solution to handle that for you is very important. And then lastly, from an identity resolution and privacy standpoint, being able to segment your data that has PII against the data that you actually want to use for identity is an important aspect from a legal perspective, from a privacy perspective. Identity resolution itself can be a difficult problem to solve just because it is more of an analytical type of problem. And so a lot of customers struggle with this in that respect. So let me talk a little bit about Neptune, and then we'll kind of come back to the use case. So when we developed Neptune, one of the things that we really wanted to focus on were 4 main tenets. The first one being that we wanted to focus on adhering to open standards. So when you use Neptune, Neptune supports two different graph frameworks, really the two different graph frameworks that are out there. One that most people are familiar with called labeled property graph, which is where you're representing data as a set of nodes and relationships or vertices and edges, and some attributes or properties on a vertex or an edge. And labeled property graph has with it a number of different query languages. There's not necessarily a standard as of yet, but the popular ones and the two that we support that are most popular, Apache Tinkerpop Gremlin and OpenCipher are the two most used labeled property graph query languages. The other framework that we use is one that you may not have heard of unless you've actually done a lot of work in the semantic web space, which is RDF, or the Resource Description Framework. RDF's been around now since the early 2000s. RDF has a query language that goes with it that was actually released in 2007 called Sparkle. And RDF actually has, again, a really good way of representing web-based properties, right? Every entity in an RDF graph is represented as an IRI or URI, and Sparkle is a declarative query language to allow you to actually traverse across what are called triple patterns in an RDF store. The other tenet is we really want it to be fast and scalable. And so the architecture for Neptune, and I'll show this in the demo, is a cluster-based architecture that scales out and also has a very decoupled aspect to it where the compute and storage scale separately, which really kind of reduces a lot of the headaches that you see with dealing with other graph applications where the scaling is pretty much all bound to adding instances, whether you're scaling for storage or compute. We want it to be secure and reliable. So we have a high availability aspect to that architecture that I'll cover. On the security aspect, we are SSL TLS by default. We integrate with IAM. The data is actually encrypted by default when you write it into Neptune. So all the different security paradigms that you see with other database services on AWS, we adhere to those with Neptune as well. And then we want it to be easy, right? I think the friction that I see the most with customers with Neptune really isn't using the infrastructure. It's getting to know the graph query languages, et cetera. And we've created a set of notebooks, Jupyter notebooks, if any of you are familiar with Jupyter, to help you get started with this easily, where you're not having to set up infrastructure to install a console or anything like that. You can actually fire up a Neptune notebook instance. And we have pre-built notebooks that walk you through the primary aspects of the query languages and with some sample data sets. So bringing this back around to our use case, this is the kind of higher level reference architecture that we see with Customer 360, the logical flow of data. Customers will have data sets in CRM systems, they'll have cookie data, clickstream data, et cetera. A lot of times that's data that has to be aggregated in some way, shape, or form, right? You don't want to actually create a clickstream and just flood Neptune with a bunch of clickstream logs, right? It's not going to scale very well. So a lot of times customers will take that data, bring it into something like an EMR or Apache Kinesis data analytics, and actually normalize the data to some aspect, aggregate it, and then take the aggregated components and then import that into the graph. You're essentially using the graph as a stream endpoint and a digest of your data, right? So, I mean, someone accesses a website, you probably get 100 logs from one page pull, right? You don't want to actually take every single log entry and their IP address and the user agent, all that stuff, and just pummel the database with that. You want to pre-aggregate it to some extent. Once the data is imported into the graph, you can do some level of deterministic identity resolution. A lot of times customers are using machine learning models to actually do probabilistic identity resolution, looking at what two entities are in common based off of common names, common addresses, things of that aspect. And then from there, once you actually have all the IDs consolidated down into known and unknown IDs, then you can start walking the graph and doing your queries and looking at what customers have certain attributes that you actually want to score and create household IDs, et cetera. So like I mentioned, trying to do something like this just purely from a relational perspective can be a little bit difficult. SQL has some aspects where you can do iterative types of recursive queries. I was about to say traversals. But using things like common table expressions is something we see from time to time. Although if you take that type of query and hand it off to a developer who's never seen that before, it takes them a while to understand that. Graph queries, the way the languages are built, I mean, OpenCipher is very much query by ASCII art in a lot of ways. You're drawing pictures to query across vertices and edges. And then OpenCipher is Gremlin, on the other hand, is very imperative in nature. It's almost like writing a stream-based query or writing a workflow in Spark. So it actually is much more akin to traversing across a graph. Inefficient processing, so like I mentioned, just the ability to actually have the edges persist in a graph database. I cannot tell you how important that is when you're trying to do this across a relational database and do joins, et cetera, across tables. Unless your indexing is perfect based off of how you're querying across it, that could be a performance bottleneck. Having those edges is almost like having an index for your joins in many aspects. And then when it comes to schema, within Neptune, we really don't have a schema. It's schema-less. There's no DDL in Neptune. So if you wanted to go and add custom-based properties to certain vertices or edges, you have the ability to do that without having to change any sort of rigid schema, table schema. And as I mentioned with the query languages, right, if you were to have something like Gremlin is very much an imperative language, right? I can actually create a Gremlin query that starts with a vertex, such as representing myself, and can traverse across that vertex as a starting point across a works at edge to Amazon. But if in the relational space, if I was to do that, I'd have to write a SQL query that actually joined that from two different tables, right? Now I actually have essentially what's akin to an indexed relationship connecting those two fields. So just a way of reiterating that. From a schema perspective, you can kind of see here just how things are constructed. Relational model on the right, you're using tables. If you want to add a column, that's non-trivial in some cases. Here, if I'm wanting to add a different family member type into a genealogy graph, I can do that without having to define anything. If I wanted to say, second cousin first removed, I'm not sure if that's actually an actual field, but I mean, you could do something like that in this type of a graph and get away with it without having to actually do much as far as changing the schema around. All right. And we have a number of customers that are using Neptune today. As you can see here, Thomson Reuters was one of our very first launch partners with Neptune. They're using Neptune as a tax use case, looking at tax law, drawing relationships across different components of tax law. Netflix uses this for data lineage. So part of their data lineage platform uses Neptune behind the scenes. Cox Automotive, we'll talk about a little bit later, but they're actually using this as a customer 360 identity graph type of platform. So I'm logged into my AWS account. I'm actually at the Neptune console here. You can see I actually have a cluster already deployed. And as I mentioned, they're kind of two decoupled components to a cluster. You have the cluster itself, which is really representative of the underlying storage in the cluster. When you create a Neptune cluster, we create this sort of virtual cluster volume where all the data is stored. And that cluster volume starts out with a capacity of 0, and it grows in 10 gigabyte segments. It can grow all the way now up to 128 terabytes in size. 128 terabytes, you're getting into the hundreds of billions of different components in the graph going up to that size. And then below that cluster, you see I have two instances here. I have a primary instance, a writer instance, and also have a reader instance or a read replica. I can add an additional 14 read replicas here for a total cluster instance size of 16. So you have 16 instances under a single cluster. We support everything from a T3 medium as the smallest instance all the way up to an R5 24XL as the largest. We also now support the R6G instance family for Graviton instances. So after you've deployed this cluster, and it'll take a couple minutes to deploy, if you want to get access to the cluster for starting to actually load data and querying, over here on the left, you'll see this section for notebooks. Here's where you can launch a Neptune notebook instance. This is based off of SageMaker notebook instances, if you're familiar with that feature. It's a managed Jupyter notebook instance, so you can use this for whatever Jupyter workload that you have. If you're not familiar with Jupyter, it's essentially a web-based Python console. A little bit more than that, but at the base level, that's essentially what it is. So here I can open up this notebook instance. And for Neptune, we load in a handful of example notebooks. We have one for getting started. Here you'll actually see there are some sample notebooks that walk you through the query languages. So if you want to get started with Property Graph and Gremlin or OpenCipher or Sparkle, you can actually use any of these. Some of them come with example data sets. We have an air outs data set, a dining with friends data set, social network data set, et cetera, that you can load in and get started really quickly. We've also added in a visualization capability, and I'll show this to you here as far as the Customer 360 use case goes, but there's some notebooks here that walk you through how to visualize data in the notebooks. We've used a library called Viz.js. It's a canvas-based JavaScript visualization tool to create a visualization of the graph. So as you're querying this, in certain use cases, it can actually generate a graph visualization for you. So you can actually see the nodes and the edges and how they're laid out. I'll come back to sample applications because that's where we're going to end up. We also have a bunch of machine learning notebooks. Again, won't talk about this here today, but if you're interested in getting started with graph-based machine learning and building graph neural networks and how that is used in reference to Neptune, all these notebooks are out here to get you started from that perspective. The main takeaway I would say from a graph machine learning perspective, the way we've integrated this with Neptune is we've added in functionality into the query languages so that you can actually access a machine learning endpoint and do inference as part of the query against the machine learning endpoint. So if you're wanting to predict edges, if you want to do linear regression against a numerical property, those types of predictive types of workloads are something that you can actually do directly from inside of Neptune using Gremlin or Sparkle currently. So from the sample applications, we have 3 different sample apps where we have notebooks that kind of walk you through the construction of these apps from a data perspective. We have a fraud graph example, a knowledge graph example, and an identity graph example, which aligns with our Customer 360 use case. There are 2 notebooks here. One actually will walk you through the data modeling exercise for identity graphs. So if you're curious about what are my typical data sources, how do I model this as a graph, this will walk you through that in detail. It also will show you some examples of, here's kind of consumer data, device and cookie data, what it looks like, kind of where this resides within, a website. But more importantly, as you get down into this, we'll actually talk about like how this is constructed across a graph, right? So how are you using the graph structure to draw connections between multiple identities? All right, the other one that we have actually goes into more detail around the queries themselves and what they look like. There is a data set from a knowledge management conference a number of years ago, I think it was from 2015, where it was fully anonymized clickstream data. Now when I mean fully anonymized, I mean down to like the URLs were hashed. So looking at the data, it's not great to look at, but the structure is there to be representative of what a real world scenario would look like. And so this is kind of the data model for that data set. As you can see here, we have persistent IDs in the identity graph Customer 360 space. A persistent ID is what you would actually think of as a known user. This is a user that has logged in to my web property. They have a username. I know who they are, maybe some address information, et cetera. You also have the concept of a transient ID. Transient IDs are unknown users. These are people that have maybe visited my website, non-authenticated, they have a cookie associated with them or a device ID associated with them. How do I actually know that might be the same person? Or how do I know they may be linked across a household? We're using all the other attributes here in this data model to make that determination. And a group identity can be referred to as kind of like a householding ID, right? So if I'm looking at multiple persistent IDs or transient IDs, all up under a single household, you can group all those together as like a group ID. So this notebook has that data set. As you can see here, we kind of load that in to our graph, pull down all these. These text files are actually all Gremlin queries. We've taken the data set, converted it to Gremlin, so you just run the Gremlin queries against Neptune to load it in. And here we're starting to use Gremlin. So these are very basic Gremlin queries, just doing group counts. So if I wanted to look at how many of a certain vertex, how many of a certain type of edge I have in the graph, I could just do a g.v group count. If you're not familiar with Gremlin, just to kind of back up the step and go over this a little bit. The G at the beginning of the query is representative of my connection to my database, right? It's actually what we call a graph traversal source object. It could typically be anything as far as Apache Tinkerpop, the spec goes. Inside of Neptune, we just always use G because it's kind of a convention of the language. The V means I want to look at all vertices. You can also start a graph query that says look at all edges. So you can see the second query down here is doing. But typically you're looking at, either looking at starting with all vertices with a filter or starting with a vertex with an ID. That's typically how most of these queries start. And then I'm doing basically a group count, which is common to most database query languages, right? And I'm group counting by a label. So you can also group count by a property or some other attribute. All right, so here's where things get a little bit interesting. So say I want to do cross-device analysis. I want to look at what two users are coming from the same device. Maybe it's an unknown user and a known user, and I want to stitch those together. I could write a Gremlin query that starts with a given user ID, which is that long hash there is the ID to start with, and then uses a series of traversal steps within Gremlin using out or in is the ways you actually traverse across edges in the graph. Out is going outward across a directional edge, inward is coming inward across the edges coming in. All edges in the graph are directional. There's no such thing as an undirected edge in Neptune. And then lastly, I'm doing some dedupe steps, and the path step actually exports the actual path. So if you actually look at the output of the query, it's akin to this. It's a path object that has every component that I'm walking across. But by exporting the path, the notebook itself triggers creating the visualization. So now I actually have a visual representation of that query walk, where I can actually go from a transient ID all the way to a persistent ID, and I can see the linkage between the two, mostly across, in this case, across a common IP address. IP addresses, some people want to use them, some people don't. Right? They're transient in nature. I would say most customers are using an IP address or any kind of ephemeral type of attributes. They're time boxing it, right? IP addresses I typically see time boxed 48 to 72 hours. People are using airport Wi-Fi, conference Wi-Fi, right? Denoting, using an IP address to denote where customers are coming from is not always a great way to do that, but there is some value to it. Similarly here, if I want to look at, maybe all anonymous users that are tied to another anonymous user, right? I can do some pretty crazy visualizations here. The library that we use, it has some physics to it, right? So I can actually drag around and re-enable the physics engine and kind of drag this. Eventually you can kind of start to see it starting to coalesce into groups. We turn that off mostly by default just because it is so processor intensive. It's using a lot of CPU from the browser, but we do expose the ability. So if you want to go back through and edit the library to make that go until it actually completely groups out, you can do that. Another use case, targeted promotions. So if I'm actually looking at, someone's looking at a specific product page, how do I link from that product page, which is represented with this URL property, to other users that have looked at that product page? Maybe I actually want to try to find a targeted ad for those, or maybe a special offer for those individuals. Audience segmentation. So in this case, I'm not necessarily drawing a graph, but you can actually look at, query all the sub-pages in my website, maybe all the product pages that I have, and see who's looking at what. How many hits do I have per sub-page, or how many individual unique users instead do I have per sub-page versus clicks? And then subsequently, I can actually pull that out. Now here, I can actually see, zoom in here, you can see this is the website vertex, and I'm actually traversing out to the sub-pages, which are in yellow, and then subsequently the actual transient IDs, and if there is a known persistent ID, the known users that are logging in and looking at those sites. All right. So this is kind of one representation. This is kind of how most users get started, right? They'll create a Neptune cluster, they'll go create a notebook instance, they'll load their data in, they'll start writing queries and doing visualization and doing some exploration. Once you've actually have created the queries and you want to actually go off and create an application, this is what it may look like. It could easily just be just a 3-tier web app at this point, where Neptune's the data store for this. Those queries would then get translated into an API layer, right? We see a lot of serverless-based applications. You can easily use Lambda and API gateway for this. I've also seen customers use things like AppSync. Probably a subject for another talk, but there are mappings you can sort of draw between GraphQL, creating a GraphQL schema, and custom resolvers and AppSync for querying Neptune. There's a number of ways you could do this. But essentially, you're going from notebooks and queries to API layer to some sort of front end. Here I have a front end that one of our other SAs created for an identity graph. And this, I can pull up just tabular format of all the customers and all their shared attributes. And this gives me the ability, I can go click on a customer using a very similar visualization framework here. I can look at how this customer may be connected to other customers, and simply by just double clicking on the different attributes here. This may be useful in something like a call center, right? Someone calls in and you want to actually look at, what other tickets have they logged, or what other products have they purchased, et cetera. Someone can actually use this to kind of click through how that person's tied to those things. It could also be looking at maybe there's 2 people in the same household calling in for a ticket. I have one customer that actually uses this. They're a big telco, and they're actually using it to draw connections in their network of 2 customers from the same neighborhood are calling in at the same time. How do I link those tickets together to know that I'm only just sending 1 truck out to solve the problem versus sending 2, right? So there's a lot of ways you could use this sort of front end for this purpose. All right. So let's flip back over to the slide deck. All right. So like I mentioned, Cox Automotive is actually using this as the backend for their Customer 360 platform. Primarily using this to stitch identities across multiple dealers, et cetera, all within the graph to provide their dealers with better information. Just some leave behinds here. There are a number of different assets that we have out on the AWS website to get started with Neptune. I would say if you don't want to take pictures of the QR codes here, if you just do a Google search for Amazon Neptune developer resources, there's a developer resources page that will pull up, and it has links to all of these things. We have GitHub repos with sample assets, as the one you saw here, the sample notebooks that are out there. There's even a getting started video series that we have, a learning path series with 9 hours of the video for you to go through if you want to get started with Graph. Not to mention, we do have some training and certification material that's out there. For certification, if you want to be a database specialist, Neptune is covered on the exam. As far as training material, if you go out to the AWS.training site, there are a few videos we've created out there as well for people getting started with Neptune. All right, and I've left my Twitter ID up here. If you have any questions that you don't ask now or don't have time to, feel free to ping me on Twitter. My DMs are open. I work with customers all over the world, constantly getting pinged on Twitter, and I'm more than happy to address any questions. All right, so at this point, any questions?
Yeah, so if you're trying, excuse me, if you have an application in mind and you're trying to figure out the best skill set to employ to build it, obviously you start with people that know SQL well. What is the kind of the best skill set to try and take a person and develop?
Yeah, so the question is, if you're looking to align skill set for building a graph-based application, what's kind of the best type of background for them to have? I would say not necessarily a relational database background. Having a DBA background does help to some extent, just understanding how things are indexed and how to actually optimize queries. But I would say having somebody that has just a NoSQL background is even better. Graph kind of falls into that space of having to actually model data to fit the access pattern. And so having somebody who's done stuff like key value store development, et cetera, is actually very beneficial. I would also say just a full stack developer helps, just from the standpoint that a lot of this is taking the queries themselves, building that API layer. That's probably a lot of the work involved. Yep. Yeah, so the question is, can a Neptune cluster be thought of similarly to an Aurora cluster? A lot of the architectural paradigms are the same. So the idea of decoupled compute and storage, scaling out to 16 instances in the cluster. A lot of the underlying primitives that we use between the two services are common. So I would just, if you look at even things like DocumentDB, all three of those services have a very similar architecture. All right, go ahead.
What if you're doing multi-tenant? What's a good approach to that?
Yeah, multi-tenancy is something we get asked about a lot. The current best way to tackle that is to create a labeling and property key scheme that has some sort of prefix on the front end, right? So if, say you have a vertex that you want to create with a label of name, you could front end that label with customer1.name, customer2.name, and then similarly with your property keys, do the same thing. The query languages, some are better than others as far as allowing you to query on those aspects. Gremlin actually has something built into it called a partition strategy and a subgraph strategy, where you can create partitions based off certain property keys, or actually create certain subgraph queries based off certain property keys. So that's kind of the main way I see most customers doing that. They're kind of building the multi-tenancy into the app layer versus letting and getting clever with the schema in the database. All right. Sure.
Do you have anything on the roadmap for sort of serverless or on-demand pricing model versus the cluster?
So the current pricing is on demand for Neptune. As far as like other roadmap things, find me after the session. We can have a talk then. Yep, go ahead.
So if you use OpenSearch on AWS, it has this nearest neighbor. Is that built foundationally on the same concept of the graph, or is it?
The KNN, nearest neighbors functionality in OpenSearch, that is different. Interestingly enough, we do integrate with OpenSearch for full text search. Everything in Neptune is effectively fully indexed to exact match. But if you're trying to do a substring query or something like that, then we actually have an architecture that allows you to actually do a full text search query from the query languages and hit a OpenSearch cluster that has a document format of the graph. And that's actually kept in sync using a change data capture feature we have in Neptune called Neptune Streams. So if you're familiar with DynamoDB streams, and a lot of people are, Any changes that occur in the graph get placed in a stream. We have a poller that actually takes that data from the stream and actually copies it into OpenSearch. So we can actually use an up-to-date OpenSearch cluster to do those full-text search queries. I've seen customers use that for a lot of different applications. I've also seen customers take like blob data that doesn't make sense to store in the graph and storing that, like a blob text string, storing that actually in OpenSearch, and then they're actually able to do graph queries and use those blobs as search criteria. So.
Is there like a decent way to transfer the data from relational database systems to Neptune database?
Yeah, so the question was, is there a way to transfer data from a relational database into Neptune? Today, we actually do have integration with the Database Migration Service, DMS. The way it works, depending on the framework you're coming from, if you're coming from labeled property graph, there is a graph mapping file that you have to create. So you're mapping columns and tables to vertex or edge labels and properties. Or if you're wanting to migrate into RDF, the RDF is much more standardized, and there's actually a standard in RDF to map RDF back into relational called R2RML, and we use an R2RML file for that mapping. Yeah, great question. I've also seen people use Glue. Glue Studio is great because with Neptune has a bulk loader feature where you can create data, put it in a CSV file on S3, and then just load it from a CSV file. And so I've seen a number of instances where people are using Glue Studio, kind of creating their ETL workflow, where they're taking source data sets, generating those CSV files, dumping them to S3, and then loading those into Neptune. So. It's the way the CSV format is, you have one format for all the vertices and another format for all the edges. Yeah. So you can either create one big sparse CSV file for all your vertice types, or one big sparse for all your edges, or create multiple CSV files for each vertex type and edge type. Yeah.
What's there a limit size on the bulk upload?
Is there a limit size on the bulk upload? No, there's not. It's kind of determined by the actual cluster size. The bulk loader it's essentially append only, and you have some control over how much resources you're going to use from the writer instance in the Neptune cluster to actually perform the load. So there's some flexibility there as far as how you want to use that.
What are the backup features for Neptune to get it similar to RDS or
Yeah, so a question around backup. There's a couple ways that customers have been addressing this. We do have a snapshot feature that's built in. So you can take a snapshot of a cluster and create a new cluster from that snapshot. If you wanted to get more kind of granular exports of the graph, we do have a Neptune export feature that you can launch. It's actually a CloudFormation template in our documentation. It uses batch and a few other AWS services to do a big parallel export for the graph. And Neptune export can do the entire graph, or you can also give it a query, so you can do parts of the graph. So if you want to do some partial export, you can use Neptune export for that. Yeah, there's a lot on, we have a Neptune tools GitHub repo that's got some interesting little tools like that we've created and open sourced. So.
Do you have any concept of time in the database where you can look at changes in the graph over time?
Yeah, so a question around the concept of time in the graph. The closest thing we currently have is Neptune Streams. So with Neptune Streams, like I said, it's just a change data capture log of all the mutations that have occurred in the graph. And we actually now have timestamps for those changes. So you can look and see like the order which those changes occurred. That's really kind of the only kind of thing we have. So if you wanted to, say, create a copy of the graph back for a certain time period, you could actually just pull from that log up to that timestamp. And that log is kept for 7 days. After 7 days, we truncate it. For obvious reasons, it would just get huge. All right. I've got stickers. So before you leave, if you want Neptune stickers, these are actually the newly printed ones with the OpenCipher logos. We just launched OpenCipher into GA. So come and get these from me. With that, we'll go ahead and wrap up. And then if you have any other questions, feel free to come up. We've got a few minutes before we have to clear the room.